Hi guys, it's Mrs. Clark. Right now we're going to work on graphing rational numbers part 2. In the last video, we took the two rational numbers that we're needing to graph and we changed them both to decimals, and then we graphed them as decimals. You may find that there are times where you might rather keep them in fraction form, so convert the decimal to a fraction. So that's what we're going to do here. We're going to look at 3.3, which is the same as 3/10. That's how we say it correctly. That can't be simplified any further, okay? Now, when you're graphing two fractions in the same location on a number line, you need to have a common denominator. When you look at 4/5, you may think, you know what, I can make 5 into 10. You could take 4/5 and multiply both parts of that by 2, and you would get 8/10. Okay, so now you would be graphing 8/10 and 3/10 on the same number line. So these are both positive fractions. So we're going to be between 0 and 1 whole. We don't have anything larger than 1. All right. And the denominators here tell us that we need to divide up our space between 0 and 1 into tenths, which means 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. Not bad, Mrs. Clark. Not bad as far as the space and how equally spaced they are. You know how I like when they fit nicely. So I'm going to graph the one closest to 0, and that's going to be 3/10. So 1/10, 2/10, 3/10. Now I'm going to put it in the form that it originally was in. You know I like that. You know that you should be using the original numbers. So we're going to put 3/10 here. But I'm also going to show I know what that is as a fraction as well. The equivalent fraction, which is 3/10. And I put that underneath too. So we have both. All right. Now we're going to graph 8/10. So we're at 3/10 here. So 4/10, 5/10, 6/10, 7/10, 8/10. Okay, and I'm going to write the original form, which was 4/5. And I'm not going to put 8/10 this time because they're basically describing the same exact fractional amount. If you want to, I wouldn't take points off, but I'm going to leave it. That's the original form, and 8/10 is actually equal to the same thing. So let's go on to another example. All right, I want to look at negatives now. I want to look at negatives. I want to look at negative 12/20, and I want to look at negative 7/10. All right. Same type of concept. I think we might want to work with fraction forms. However, if I look here, I'm looking at a fraction that's not in simplest form right now, so I might want to start by simplifying. If I divide both parts of this by the largest number they have in common, which is 4, let me make these a little darker. If I divide both of these numbers by 4, I get 3/5, negative 3/5, okay? And now if I go over here, and I look at this, it's negative 7/10. Negative 7/10. Okay? So now, if I have to put these on the same number line, I could very easily take this, negative 3/5, and build it up to have tenths. I could multiply both parts of this by 2, and that could give me negative 6/10. Okay, negative 6/10. So I've got negative 6/10, and I have negative 7/10 right here. So now I can put these on the same number line. All right, I am going to be, this time around, I am not on the right side of 0, I am on the left of 0, and I'm between 0 and negative 1. I'm dividing my number line into tenths, so that's 9 lines again. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And now I have to be mindful of the fact that the number that's closest to 0 is actually bigger. So which one of these numbers is closer to 0, -6 or -7? You say -6, and I agree. I start at 0 and I count -1/10, 2/10, 3/10, 4/10, 5/10, 6/10. Plotting my point, writing the original fraction. And this time around, you could put -6/10. All of these fractions here are equal to the same thing. They're all equal, they're all equivalent, okay? So you don't have to go crazy putting them all on there, but it's really so you remember, where did that -6/10 come from? How did we get there? All right, so now remembering that 7/10 is 1/10 less, and I'm coming off the camera, here we go, 1/10 less than 6/10, that means I'm going one more space to the left. So I'm going one more space to the left, and that puts me here. These are super close, okay? And this time I'm gonna write above it so I have plenty of room. The original number was in the form of the decimal, so I'm gonna put it that way. And maybe I'm gonna put above that -7/10, so I know that they are the same thing. Okay, hopefully this lesson helped. I know this takes it to a whole other level. It's definitely getting harder, more challenging. You can decide, okay? You can decide whether or not you want to work with fractions or if you're more comfortable working with decimals, but what you do need to remember is you really should be graphing them in the same form, either all decimals or all fractions, okay? You could do percents, but percents get a little bit tricky because some of these numbers, if I give you 7/10, okay, that 7/10 is not equal to 1 whole yet. So I'm worried that if you try to graph percents, that you're going to be somewhere in the way larger than 1 whole. So I would stay away from graphing percents at this point. I would stick to working with decimals and fractions. I hope this lesson helped. We'll practice it together.